between natural language processing, natural language understanding, and formalization in grammars. So it's my pleasure to introduce to you today Robert D. Van Valin Jr., who received his PhD in linguistics at the University of California, Berkeley, in 1977. He has taught at the University of Arizona, Temple University, the University of California, Davis, and the University of Buffalo, State University of New York. Between 2007 and 2017, Van Valin was professor of general linguistics at the Heinrich Heine University of Düsseldorf. In 2006, he received the Research Award for Outstanding Scholars from outside of Germany from the Alexander von Humboldt Foundation. In 2008, he was awarded a Max Planck Fellowship from the Max Planck Society. Currently retired from teaching, Van Valin fully keeps his research activity, focused on theoretical linguistics, especially syntax and information structure, and as well on the SESIÓN language Lakota. Van Valin co-authored with William Foley the first version of role and reference grammar, published in 1984. For nearly 40 years, Robert Van Valin has led the development of RRG and guided the gathering of a strong community of researchers, inspired by Van's persuasion that linguistic structure cannot be explained without reference to meaning and information, and that linguistic diversity must be taken seriously. But Van Valin's success in gathering and maintaining the RRG community is not only due to the appeal of the theoretical notions of RRG, some of which have been extensively cited and followed. Van's attitudes of curiosity, respect, and integration of converging approaches have clearly left his mark on several generations of linguists, many of whom have been directly supervised or taught by him. Throughout these years, RRG has been successfully applied to over 100 languages, while more than 1,000 publications draw on this theory. The 1997 handbook, usually called the Red Book, Van Valin La Pola, was updated by Van Valin 2005, and a new major handbook of RRG is expected to come out in 2024. And last but not least, the RRG conference has been held biennially since 1999. Today, it is an honor to introduce to you a master of linguistics and an exponent of the finest American tradition of syntactic theory and linguistic relativism. The person who has taught us many of us that languages can only be explained in their own terms, and that is compatible with a strong theoretical apparatus. Professor Robert D. Van Valin Jr. The floor is yours.
Thank you, Javier. It's nice to be back in this room again. As I came in the building, I recognized the room and where we had a conference in 2014. I should mention, Javier mentioned the Handbook of Role and Reference Grammar. I'm happy to say it's going to come out in June in Europe, and for some reason I don't understand, it's not going to come out in the States until the fall. But so you all will get first shot at it. And I should say there are two people from Spain involved with it. Ricardo Mayral Uson, who was one of the editors and contributed an article, and Luis Paris, who contributed an article. Okay. Role and reference grammar strives to be a component of a model of the communicative competence of a native speaker of a human language. Following Kaplan and Bresnan in 1982, It is incumbent upon theories making such a claim to be implementable in testable models, psycholinguistic or computational, of language processing. Even though RRG is a theory of grammar and not a model of language processing, its architecture suggests that it can form the basis for a processing model. So this is familiar to most of you, I guess. The thing that's relevant to processing is the bidirectional linking algorithm. So the system links from semantics to syntax, which imitates or is similar to what a speaker does. That is, he formulates a message, creates a semantic representation, maps it into a syntactic representation, and then utters it. Hearer, on the other hand, takes that syntactic representation and interprets it, which in this case means maps it into a semantic representation. So in an abstract way, the bidirectional linking algorithm covers what speakers and hearers are doing in an abstract way. The purpose of this talk is to present one possible adaptation of RRG as a processing model, starting from the proposal in Van Valen 2006 and extending it to the model developed in Van Valen 2023. The discussion will proceed as follows. 1. An overview of the features of RRG which have to be fixed, so to speak, in order to use it as the basis for a processing model. 2. The syntax to semantics linking algorithm. 3. The comprehension model proposed in Van Valen 2006. Number 4. Unresolved issues in the 2006 model. 5. The RRG semantics to syntax linking algorithm and a model of production. 6. The incremental nature of production and comprehension. And 7 is conclusion. While the semantics to syntax linking algorithm captures some aspects of production, it fails to capture the fact that production is incremental and that a speaker may start a sentence without any clear idea of how it will end. I'll have more to say about this later on. Similarly, the syntax to semantics linking algorithm makes two assumptions which are not compatible with the results of psycholinguistic investigations. First, the system outputs a complete parse tree that is then interpreted, which is incompatible with the fact that comprehension is incremental and begins when the first word of the sentence is encountered. If you want to make a room full of psycholinguists laugh, just tell them that the parser outputs a complete labeled tree and it gets then interpreted. 2. It assumes that displaced WH words are linked after all of the core arguments are linked, whereas speakers try to resolve WH expressions as soon as possible. Another issue is the speed of processing. Syntactic analysis starts in as little as 120 milliseconds after initial word recognition, and the subjective impression that speakers have is that interpretation is normally instantaneous. In other words, it seems to language users that they access the meaning directly. The RRG syntax to semantics linking algorithm is summarized as follows. Preliminary, the parser outputs a labeled tree structure. B, the first step is to derive as much information from the overt morphosyntactic features of the clause: case marking, word order, voice of the verb, add positions, agreement. The second step is to retrieve the logical structure of the predicator in the nucleus and assign macro roles where possible. D, the information from these two steps should link everything in the core to the argument positions in the logical structure. If there is a displaced element in the pre-core slot, it will be linked last to the remaining unlinked argument position in the logical structure. So a simple example, almost the simplest possible example for the semantics to syntax linking algorithm: the parser outputs a tree structure, and then step 1 occurs, and since English is a language with a voice system, the voice of the verb is important because it tells you the semantic function of the PSA or subject. So voice is active, therefore the PSA is the actor, and the PSA or subject is the first RP in the core, and the direct RP immediately following the nucleus is the undergoer. So Kim is labeled the actor, Glass is labeled undergoer. The second step is to go to the lexicon, pull up the logical structure for smash, and assign macro roles where possible. Well, in this case, you can say the X argument is going to be the actor, and the Y argument is the undergoer. And step 3 is to link those two things up. So Kim is the actor is the X argument, therefore Kim is the X argument. Glass is the undergoer is the Y argument, and therefore Glass is the Y argument. So this is about as simple as it gets. Because interpretation occurs simultaneously with parsing, the RRG linking system must be integrated into the parser. One way this could be accomplished is suggested by the approach to sentence comprehension proposed in Townsend and Bever, 2001. They postulate a two-phase comprehension process. The first is termed pseudo-syntax, which is statistical and yields an initial assignment of syntactic structure and thematic relations. And the second, which they call real syntax, is a minimalist derivation to interpretation of the sentence. They characterize it as follows. Pseudo-syntax consists of the immediate properties of verbs. The frequent sentence patterns referred to above are labeled canonical sentence templates, with the most frequent one being NVN, actor, action, patient. They marshal a substantial amount of experimental evidence in support of the role of canonical sentence templates in pseudo-syntax. Hence, pseudo-syntax is essentially statistically driven templatic parsing, in which templates contain information about the thematic relations of the phrases. It assumes the existence of a matching mechanism that will associate the canonical sentence templates with the sentences encountered. It results in what is called good enough comprehension, or the basic who does what to whom meaning. RRG makes use of syntactic templates, and the core templates are for the most part bare pieces of the layered structure of the clause, which are unspecified with respect to the types of phrases that fill the slots in the template. Consequently, they also have no information regarding the semantic function of the possible phrases that can occur in them. All of that information is supplied by the linking algorithm. The first step in transforming bare syntactic templates into pseudo-syntax parsing templates, or more accurately, linking templates, is to augment them with phrasal category information. And accordingly, Townsend and Bever's default canonical sentence template for English would be RP nucleus RP. The other crucial aspect of canonical sentence templates is the assignment of thematic relations to phrases in the template. Here again, RRG takes a different tack from Townsend and Bever. Rather than augmenting the templates with thematic relations, the RRG templates would have the semantic macro roles of actor and undergoer. Hence, the default canonical template for English would be RP actor, nucleus, RP undergoer. It is represented in Figure 3. So this is the simple English transitive template. You've got two RPs in the core. The one in the subject position is labeled actor. The one in the object position is labeled undergoer. You have slots for tense and illocutionary force, which are the required minimal operators for a main clause in a simple sentence in English, and you have an optional peripheral adjunct. This template has the core RPs annotated with semantic macro roles. In addition, the operator projection carries empty representations for tense and illocutionary force, the obligatory operators in a finite main clause in English. The exact values of these operators are a function of the clause being processed. There is an optional place for peripheral adjuncts. Only the core level periphery is shown here, but there may be peripheries modifying the nucleus, core, or clause. The next two templates are for three-place predicates and passive constructions. So Figure 4 is the three-place predicate template. In this template, the non-macro role third argument is an oblique core argument marked by a non-predicative preposition. If it were the double object construction, then the non-macro role would be an RP, as in John gave Mary the book. The passive template differs in that the initial RP in the core is labeled undergoer, and the actor is optionally in the periphery, core level periphery, marked by, and the nucleus contains the auxiliary B, which is a necessary part of the formation of a passive nucleus. The second component is the lexical entries for verbs and other predicators. These contain not only the logical structure of the predicator, but also the macro role arguments of the arguments in it. The two things that are most important for the rapid interpretation of a template is the assignment of semantic macro roles and non-predicative prepositions. For a simple transitive verb like kill or smashed, the logical structures would be as in to. So in general, you have do X, something affecting Y, cause Y to undergo a change of state resulting in the state characterized by the pred. With kill, it's dead, so X affects Y, causing Y to be dead. And smash, X does something affecting Y, causing it to be smashed. Once the template in figure 3 has been matched and the verb recognized, the basic who did what to whom meaning is available by integrating the arguments from the template with the logical structure. This can be illustrated with the burglar smashed the window. So the matching mechanism selects the template in figure 3, yielding the first RP in the core carries the actor designation, and it's the burglar, the nucleus is smashed, the immediate post-nuclear noun phrase carries the annotation undergoer, and it's the window. The lexical entry for a predicate in the nucleus is activated, and the annotations on the arguments in the template and the logical structure guide the interpretation. That is, the RP with the A notation is the burglar, the A argument is the X argument, therefore the burglar is the X argument. Similarly, the RP undergoer is the window, the U equals the Y argument, therefore the window equals the Y argument, yielding the interpretation. The burglar is the actor, and the window is the undergoer. The assignment of syntactic structure and the semantic interpretation are accomplished rapidly thanks to the annotations shared by the templates and the lexical representations. Things are a bit more interesting when there are more than two arguments. A good example of a three-place verb is the transfer predicate present. Its logical structure would be do, affect, X, Y, cause, ingressive, have, Y, Z. Present, like most three-place verbs in English, permits more than one possible choice of the undergoer macro role, and this choice is signaled by the preposition assigned to the non-macro role argument. Rather than invoking macro role assignment rules and preposition assignment rules as in an RRG grammar, the lexical entry for present simply presents both possibilities, as in 3. So you have two possibilities: present the award to Mary, in which case Mary is the Y argument marked by 2, and the award is the undergoer, which is unmarked. Or you could have present Mary with the award, where Mary is the Y argument again, but the undergoer, and the award is the non-macro role marked by with. Once the template in figure 4 has been matched and the verb recognized, the basic who did what to whom meaning is available by integrating the arguments from the template with the logical structure. The comprehension of a passive sentence, for example, the window was smashed by the burglar, is just as straightforward. The matching mechanism selects the template in figure 5, yielding the first arps in the template and the logical structure guide the interpretation, i.e. the prepositional phrase carrying the A annotation by the burglar equals actor equals X, therefore the burglar equals X, and the same thing with the window. yielding the burglar is the actor and window is the undergoer in the final logical structure. There were two issues mentioned at the beginning of this section that RRG has, as a processing model, must address, namely incremental interpretation and displaced WH questions. Incremental interpretation can be in fact accounted for in terms of parallel processing of linking templates. At the first word in a sentence, there are many possible candidate templates, and as each new word is encountered, the number of candidates is reduced until the correct combination of templates is chosen. This winnowing process is essential to the comprehension process. Displaced WH questions are handled by the templates in figures 6 and 7. So the first figure 6 is a subject WH question where the subject RP is in the pre-core slot and the auxiliary may or may not, you don't have to have an independent auxiliary. You can simply say, who ate the sandwich? In contrast, the non-subject WH question must have an auxiliary, and the auxiliary must occur after the WH expression and before the subject RP in the core. And so if there is no auxiliary, then you get do in a non-subject question. An example of a simple WH question and its analysis is given in 4. Not A means not the actor argument of an active voice, transitive, or three-place verb in the main clause. So the question is, what did Mary present to Sam? The matching mechanism selects the template in figure 5, yielding in the pre-core slot we have the RP with the not actor annotation, and it's what. Then we have the core, and did is in curly brackets because it's actually in the operator projection, not in the constituent projection. The first RP in the core is Mary, labeled actor. Nucleus is present, and the non-macro role is to Sam. The lexical entry for the predicate in the nucleus in 3A is selected because of the non-macro role to specification and is activated, and the annotations on the arguments in the template and logical structure guide the integration. So Mary is the RP with the A annotation. The A argument is the X argument, therefore Mary is the X argument, etc., leading to the interpretation Mary did something affecting the Z argument, causing Sam to receive the what? The Z argument. The minus WH expression what is integrated into the logical structure as the U, since undergoer is a kind of non-actor. There are linking templates for various kinds of complex sentences, but we will not go into them here. What happens when breakdowns such as garden paths occur? What happens when an unfamiliar structure is encountered? These are situations in which step-by-step reanalysis and reinterpretation are required. On top of the template-based processing discussed above, there is also the possibility of step-by-step processing as well. In this mode, the syntactic representation of the sentence is constructed, and then the steps of the syntax to semantics linking algorithm are carried out literally, which permits double checking of all the relevant aspects of the construction. All of the examples of linking with semantically augmented syntactic templates have been from English, which has relatively rigid word order, which is crucial for the interpretation of core arguments. Can this approach to language comprehension be applied to languages with various degrees of word order flexibility and which rely on case marking rather than linear order for the interpretation of core arguments? The answer is yes, and the application to case marking languages with very flexible word order will be illustrated with an example from Croatian. So Croatian has a verb, darovati, meaning to give as a gift. And we have an example. The grandsons gave flowers to their grandmother. So grandsons is masculine plural nominative, grandmother is feminine singular dative, flowers is masculine plural accusative, and we have the thing given in the accusative case and the recipient in the dative. And given Croatian's flexibility of word order, B, C, and D are possible permutations of A, and they all mean the same thing. Grammatically, they may not be all the same pragmatically. They may be used in different contexts, but the event they describe is the same. The Croatian verb darovati, give as a gift, is a three-argument transfer verb like English give or present. The logical structure in 5 has the same semantic annotations as in 3, and it represents the meaning of all of the sentences in 5A through D and the many other possible arrangements of these 5 words. The only thing that is invariable in terms of word order is the occurrence of the word su as the second word. It is a kind of auxiliary verb which shows person and number agreement with the nominative RP and must always be the second word in a sentence. Interestingly, darovati shows the same undergoer alternation that present does. So you can also say, the grandsons gifted their grandmother with flowers, where the grandsons are the actor again, but the grandmother, the recipient, is now the accusative undergoer, and flowers are instrumental plural. And these 3 word order variants are all possible and mean the same thing. In 6 but not 5, the Y argument in the logical structure is the undergoer, and the Z argument is the non-macro role argument in the instrumental case, which is analogous to the instrumental preposition with in English. As in 5, all of the examples in 6 have the same meaning. The crucial difference between 5 and 6 is the coding of the non-macro role argument, dative case in 5 and instrumental case in 6. Accordingly, it must be specified in the logical structures for darovati, as in 7, just like in 3 for English present. So we've got your basic transfer logical structure, and in A you have the non-macro role argument is Y in the dative case, and the undergoer is Z in the accusative case. And in B, you have the undergoer is the Y argument in the accusative case, and the non-macro role is the instrumental case marked Z argument. It is clear from the examples in 5 and 6 that the interpretation of the core arguments is based on case marking. In Van Valen 2006, case association principles were used to handle the linking between case forms and macro roles. The grammar of Croatian includes the ones in 8 as well as the additional ones for cases not found in 5 and 6. The nominative case codes the actor with some intransitive verbs and active voice, transitive, and ditransitive verbs, and it codes the undergoer with some intransitive predicates and with passive voice, transitive, and ditransitive verbs. The accusative case marks the undergoer of an active voice, transitive, or ditransitive verb. The other two cases mark non-macro role arguments, dative arguments being direct core arguments, while instrumental ones are oblique core arguments. In RRG, whether a reference phrase or a prepositional phrase is a core argument or not does not depend on its place in the linear string. Languages may impose linearization restrictions, of course. This means that syntactic templates which represent the layered structure of the clause need not have a fixed order, and this is what languages like Croatian require, unordered templates. The only ordering constraint in Croatian is in the clause concerns the auxiliary, which must be the second word in all clauses. This can be represented as in figures 8 and 9. So we've got two linking templates. I don't know if you can, they look like they're dotted, but the lines to RP nominative A, RP dative non-macro role, RP accusative U, and the nucleus are all dotted, meaning they can occur in any order. The only fixed line is the aux line, so the core aux lexical string, that's fixed. Everything else can occur in any order. Similarly, in figure 9, the only difference is that the non-macro role is instrumental rather than dative, and otherwise the lack of ordering constraints is the same. Language comprehension is modeled in an RRG grammar by the syntax to semantics linking algorithm. In order to create a plausible processing system, two major changes to the system were proposed. First, the bare syntactic templates of the grammar were augmented with syntactic category information and semantic macro roles, yielding linking templates. Second, the logical structures of verbs and other predicators were augmented with semantic macro roles, and the adposition or case carried by the oblique core arguments. The result is that parsing and syntax to semantics linking are collapsed into two steps, as illustrated for a variety of examples. What implications do these changes have for the linking algorithm for mapping semantics into syntax, which underlies possible models of language production? This question was left open at the end of Van Balen 2006, where it was noted that there were now two sets of syntactic templates in the theory: the bare templates used in linking from semantics to syntax, and the semantically augmented linking templates used in linking from syntax to semantics. There are two sets of logical structures as well: the pristine logical structures used in semantics to syntax linking, and the morphologically and macro role enhanced logical structures used with the linking templates in syntax to semantics mapping. There is clearly a great deal of redundancy here that needs to be resolved. The semantics to syntax linking algorithm will just be summarized here using the example Max was interviewed by CNN during the insurrection. The operator projection is omitted. Step 1, construct the semantic representation of the sentence based on the logical structure of the predicator. So we have the activity verb to interview. The actor is CNN, the first argument is CNN, the second argument is Max, and you have an adjunct temporal preposition during, modifying the main predicate. Determine the actor and undergoer assignments following the actor undergoer hierarchy. Well, CNN is the leftmost argument in the logical structure of the main verb, and Max is the rightmost argument, so Max is the undergoer. Step 3, determine the morphosyntactic coding of the arguments: PSA selection, case assignment, add position assignment. So CNN is the actor, and because the PSA is not the actor will occur marked by. The passive is invoked. The auxiliary be is necessary, and it takes the past participle form. And the undergoer is the PSA and will be nominative if a pronoun. Step 4, select the syntactic templates for the sentence following the template selection principles. So we come up with this template. Step 5, assign arguments to positions in the syntactic representation of the sentence. So we have the information, the morphosyntactically enhanced logical structure. We have the syntactic tree structure, and now we can map the lexical items into the tree structure. The steps in 9 involve applying rules, assign macro roles, select the PSA, assign case, etc., selecting a bare syntactic template, and then inserting lexical items into the template. The content of these rules is the same information contained in the linking templates and morphologically augmented logical structures in the comprehension system, and this is no accident, of course. As an alternative to applying these steps sequentially, it is possible to condense the linking into constructing the semantic representation using the augmented logical structures with 1, lexical choices of the argument positions in them, and 2, operators. Selecting the passive linking template in Figure 5 and integrating the two. This can be illustrated as in Figure 10. The augmented logical structure is given below. So we have the logical structure given again where you have CNN is labeled the actor and Max is labeled the undergoer. And we have the passive linking template. And if we simply using the annotations say, okay, CNN goes in the preposition phrase headed by, and Max goes to the PSA slot, we get the semantics to syntax linking in basically one step. The semantic representation is composed of two logical structures, do A, X, interview, X, U, Y, and B during WZ. The lexical items filling the argument positions in them. The logical structure for the interview fills the Z argument position in the prepositional logical structure, and the values for the minimally required operators. It is integrated into the passive template from Figure 5 using the annotations on the linking template. The undergoer Max occupies the core initial PSA position, which carries the undergoer annotation. The actor CNN appears as the object of the preposition by in the core level periphery due to its actor annotation, and the adjunct temporal preposition during heads a prepositional phrase, which is also in the core level periphery. The general features of the construction, those that are cross-linguistically valid, as well as the language-specific idiosyncratic features, for example, the verb morphology, are contained in the constructional schema associated with passive templates. Thus, the 5 steps in the linking algorithm in 9 have been reduced substantially to a fast production process, analogous to the reduced comprehension process described earlier. In 9, the actor-undergoer hierarchy, the PSA selection hierarchy, and the add position assignment rules, among others, play a role in the grammar version of the linking algorithm. They represent important, linguistically significant generalizations captured in RRG. Are they lost in the condensed linking in Figure 10? They are not lost, but their status has changed. The actor-undergoer hierarchy, for example, governs macro role assignment in Step 2 and 9. There is no macro role assignment per se in the process in Figure 10. Both the linking template and the logical structure of the main predicator have macro roles specified in them. The linking regularities captured by the actor-undergoer hierarchy are generalizations across logical structures. In other words, the generalizations expressed in the actor-undergoer hierarchy are now meta-generalizations across logical structures rather than being a rule constraining the assignment of macro roles. The logical structures in 2 express the basic relations with an M-transitive verb, while the logical structures in 3 and 7 lead to the meta-generalization that variable undergoer choice is possible with certain 3-place verbs in certain languages. This also holds true for PSA selection, add position and case assignment, etc. Thus, the constraints and rules as well as the hierarchies that inform them are not invoked as grammatical operations to be applied sequentially, as in 9, but rather conceptualized as abstract meta-generalizations across the linking templates and the augmented logical structures. One of the daunting challenges facing language processing models, both of comprehension and production, is accounting for the incremental nature of processing. The issue was addressed for comprehension, where the solution was to postulate parallel template processing, whereby the number of competing templates is reduced as the system encounters more and more of the input until eventually there is a single templatic structure remaining for unambiguous sentences. With production, on the other hand, the issue is that speakers can start an utterance without having planned it to the end. And according to linking in 9, is an idealization which assumes that the entire utterance is planned out in advance. In reality, the semantic representation in 10 is compatible with the possibilities in 10, among others. So we have CNN interviewed Max during the insurrection. During the insurrection, CNN interviewed Max. During the insurrection, CNN interviewed Max. Max was interviewed by CNN during the insurrection. During the insurrection, Max was interviewed by CNN. During the insurrection, Max was interviewed by CNN. The speaker has to decide whether the main clause is to be active or passive voice, and whether the temporal prepositional phrase is to occur in its default position in the core level periphery or in initial position, and if initial, whether it is a frame-setting topic in the pre-detached position or part of the assertion in the pre-core slot. If the speaker begins with during, then 10A and D are eliminated, but the remaining 4 are still possible. If they begin with CNN, then only 10A is possible, and likewise if the utterance is max, only 10D is possible. There are different commitment points in the sentence. If the speaker starts with a prepositional phrase, the speaker is not yet committed to the voice of the main clause, whereas if it starts with a reference phrase, the speaker is committed to the form of the main clause and the placement of the prepositional phrase. This example has assumed that the speaker has decided on the predicator, but it is not unusual for there to be competing predicators with different implications in play. An alternative way of describing Max's encounter with CNN would be with the verb talk to as in 11, Max has talked to CNN during the insurrection. The speaker has options for the semantic representation as well as the syntactic form of the sentence, and for the sake of the discussion, it's assumed that Max is the topic, and so the topic expression, the RP Max, will be the PSA of the main clause. Consequently, the main clause beginning with Max has can be continued with either been interviewed by CNN or talked to CNN, reflecting two very different syntactic patterns. A speaker can begin a sentence without deciding on a final structure for the utterance. Okay. Because structural templates play a crucial role in the processing system, the incremental nature of processing is captured by competition among the possible templates, which is resolved at critical points during the sentence. For comprehension, the number of potentially relevant templates is reduced word by word as the receiver processes the sentence linearly. The result of this winnowing should ideally be a single structure with a single meaning, and multiple structures and meanings create ambiguity. For production, the speaker can begin uttering a sentence without having decided on the final form and meaning of it. Here again there are semantic representations and structural patterns competing, and the choice is made at critical points or a function of the speaker's intention to communicate a particular message. It has become clear that in order to use an abstract competence grammar for language processing, both production and comprehension, it is necessary to make changes to the system. In particular, the rules and constraints that the abstract grammar employs in mapping between meaning and form and between form and meaning are pre-compiled in the syntactic templates and the logical structures for verbs and other predicators. These linking templates and augmented logical structures play a central role in both production and comprehension, affording rapid and direct coding in the case of production and what naive speakers perceive as nearly instantaneous interpretation with respect to comprehension. There are therefore two versions of RRG, the familiar abstract grammar in Figure 11 and the processing system in Figure 12. So in the processing system, you have the linking template inventory, consists of linking templates and constructional schemas, and the lexicon consists of the augmented logical structures. And you have winnowing going on in both directions. I haven't talked about discourse pragmatics at all due to it would make this talk even longer. Conclusion. This talk began with a reference to Kaplan and Bresnan's assertion that there should be a link between abstract competence grammars and processing models. It has been argued that the mechanisms of RRG can be the basis for models of both language comprehension and production, and the exact nature of the adaptations required by the processing models have been articulated explicitly and summarized in Figures 11 and 12. The generalizations expressed in the RRG linking algorithm are captured as meta-generalizations in the processing model. RRG thus meets the requirement that a grammatical theory claiming to capture speakers' linguistic competence should be able to be used in a testable psycholinguistics processing model. Thank you.
Okay, we have some time for questions.
Luis.
Sometimes like, how many days? Man, well, first let me mention that since we are in a Spanish-speaking context, we wrote like 3 or 4 papers in Reina language, experimental psychology. And I don't really
she convinced me that incremental production is just as complicated a problem as incremental comprehension, and it's exactly what you said. I mean, we have this idea that there is an idea and there's a semantic representation that the speaker's committed to, and it gets mapped into the syntax, and that's not the case.
Yeah. So I'm glad that you have that evidence, and I will read the article of this person you mentioned.
So-
Who was the person who gave you the evidence?
Kay Bach.
Okay.
She's Bach and Leyfeld.
It is great because we are running some experiments, and our assumption is that there are, very marked differences in social
British linguist named Basil Bernstein, who studied language differences in British social classes.
Right.
And so you're aware of Bernstein. Good. Because I was going to think you would want to read him if you're studying language and social class, in terms of cognitive ramifications, Bernstein was quite controversial, to put it mildly.
Right. Well, I mean,
He wasn't politically correct for the 60s.
I'm not popular in Argentina either by naming this
Yeah.
because people think that this is discriminatory.
Mm-hmm.
I think that, you know, this is reality. And I want to change reality. I want to change the way these low-income kids are taught, and you know, so anyway, your position that, you know, language and thinking goes hand by hand is very, very handy for me.
Okay, thank you. We are really running out of time, so thank you very much indeed for a very enlightening lecture.
I'm gonna try and set up here if that works.
talk in this session by John Sbol, who is Chief Technology Officer of PAT Inc., and who's going to give a talk entitled Emulating Language with RG, the Ultimate Machine Interface. John Ball is a scientist and engineer specializing in theoretical cognitive science. He has a Bachelor of Science from the University of Sydney, a Master of Cognitive Science from the University of South Wales, and an MBA from Macquarie Graduate School of Management. He applies new and emerging brain-based technologies to computers underpinned by his own pattern theory. A hierarchical bidirectional model in which a brain only stores matches and uses linked patterns. This has led to patterns which are currently being commercialized by natural language understanding company, PAT Inc. This software platform provides strong evidence that problems with human languages can be solved without processing, and particularly with the help of the linguistic framework of role and reference grammar. So, Troy, yours.
Thank you, Javier. Thanks. Well, it's an honor to be here today, and particularly to talk about something that I've now been working on for most of my life, how to understand language, and I'll explain how the role and reference grammar comes into play as I go along. But today's talk, for those of you who weren't up on the Spanish behind me, role and reference grammar, RRG, in Spanish, about Spanish. And I'll be talking about how we're working with English, but we also want to work with Spanish, as the same system should apply without much change at all. So as introduced, I'm the founder and CTO of PAT Inc. What we were trying to do back in 2006, when I started this project full-time, was take all that I'd learned about cognitive science and apply it and produce a parser. And since that point, I've realized that parsing is not the solution. There's a better solution based on meaning and discourse pragmatics or context. And most of the time when I'm talking to people, they don't know what I'm talking about because I'm not normally talking to linguists. So it's a real honor to be here and at this event, as well as obviously the people who are watching remotely. So I thought I'd just have to have one attempt at doing this properly and say where I am. So I'm at the University of La Rioja in Logroño. And that's probably harder than the rest of my presentation today. Okay, so what is NLU? We're based in Palo Alto in California, and it's one of the homes of the tech giants of the world. And back in 2014, NLU was defined as natural language understanding, the ability to take a sentence and map it to an intent. And then when you have the intent, you can do something. And for an English speaker, it sort of sounds like they're taking something that has meaning, natural language understanding, and converting it into something that it's not. Because to me, it's not understanding just because I can say, well, that means this. And here's a great example. This is one of the early examples. I saw her duck. Now, if I want to now store this in a lossless format, I'm going to have a lot of trouble, because to me that means two things. Firstly, I wouldn't say it because of Grice's maxims. Thanks, Van, for all your help over the years to explain who Grice was and why that's important. But we would say, I saw that she ducked, maybe, or I saw her pet a duck, something like that, so that it's unambiguous. But I saw her duck is obviously ambiguous, and it's therefore not usable. So what we have to do is solve that problem. In human language, we solve it by asking a question. Do you mean drop her head, or the thing that was flying around? So if you're looking for a solution to the problem, here's drawing Van's model, the triangular model of syntax to semantics and context, or in discourse pragmatics. And for me, that pretty much says everything you need to know. So that context piece there is about, well, what does it mean at this point in time? people also in my center of the universe in Silicon Valley often talk about context being a bunch of documents that they've ingested in some sort of machine learning algorithm, but obviously that's not what it is. It's, you know, what was the last sentence and how does that relate to what I'm saying now so that I can work out the discourse pragmatics between them. In terms of NLU, I look at the syntax being the words and phrases in a language, because we've entered 9 languages at this point, and as we were doing it, we were realizing you can do a pretty good split between the words and phrases in a language and then the meaning and the relations that those have. And just to start off, we've had this major breakthrough in our work. Thanks again to Van for pointing this out. But if you start with syntax as the center of the world, and all you care about is parsing that sentence, then you're going to feed it into some other system. You've got the problem that firstly, you might not know what the structure is because I've just given you an ambiguous sentence that you can't resolve out of context. And if you think about the richness of the meaning, when you do the analysis, it turns out that often the meaning is has a lot of information. Is it a predicate or a referent? And if it's a semantic predicate, you know that it has arguments. If it's a referent, you know that it has some sort of structure. And we can take advantage of that. So just drawing out why NLU is important. So language understanding is about understanding conversation. So I'm putting on the left-hand side there the words and phrases in the language. So that's language specific. And on the other side, I'm putting language independent. So that's our dictionary of definitions plus the other language independent part, which could be the context. So if you're publishing a book in a meaning format, then that's going to be language independent. So here's the vision. This is the big goal of PAD Inc. We want to be able to take, for English, customize the dictionary so that we know what the words mean. We want to link it using the RRG linking algorithm to its dictionary definition, and then based on its predicator type, then produce something that we can then store as context. And so, for example, if the Wall Street Journal took its articles for today and it published them in a meaning-based format, so it went through from, say, English into this meaning-based format, and then somewhere else around the world you access that and you generated it into your language, you've suddenly got a much better way of communicating with people. And obviously a lot of things follow on from that, better search engines and better access to information. So today, because this is a discussion about RRG in Spanish, we can just put one new little factory there, the Spanish factory, and that's going to have the words and phrases in Spanish, which are linked and tested to get through to the representation. So all of what Van said, the good news for me is I don't have to worry about all of that real complex detail as to why all these things work. I just have to implement it and have linguists say, here's my example set. You know, maybe it's 100,000 sentences that we have to get right, but if we process all of those sentences and get the right answers, then the system is working correctly. And that's the approach that we're taking. So here's the more filled out version with lots of languages. We've got some big visions to achieve here, but on the right-hand side, right, you can see lots of people could potentially publish in a meaning-based format, and on the left side, you could just keep adding languages, making sure that you do it correctly with the right linguistics, and then we've got a much happier world to live in. Okay, so hopefully, Beth, you can give me like a 10-minute knock and another 10-minute knock so that I don't completely go over time. So I'm going to talk about the components of the system, the meaning matcher, which is basically taking a sentence and converting it into its role and reference grammar-logical structure. I'm then going to show how what we did, in fact, when I first met Van, that was 2012. So in 2013, we did our first conversation test where we took the meaning of the sentence, and then using only the meaning, we found out what the answer should be, and then based on those answers, we pushed it through the RRG generator to then produce it as an answer. And I'll show you how that works. Commercially, we're focused on another step, which is, okay, well, you can understand the language, but it would be really handy to be able to lead somebody to a goal. So the goal-directed conversation is more than just, you know, you contact your airline, for example, and you say, I want a ticket, and it says, sure, and then you just sit there because nobody's directing you to the goal. Like, what's your name? When do you want to go? Where else do you want to go? What class do you want to go? So those are the ways of working with a goal. And then we should have 15 minutes for questions and answers at the end. Okay, so here's our meaning matcher to kick off with. I'll put my glasses on just so that I can see what's going on. Here we're going to be skipping through all of the linking steps in the RRG linking algorithm, but if we just start with something simple, Susan is tall. Is that visible okay? I'll make it a little bit bigger and then we'll... So what I want to point out is here there's our logical structure. So Susan has this attribute of being tall, so Susan is tall. And as we work through, I'm not going to run through all these examples, don't worry. A little bit big? Sure. So, okay, good. So here's the second example. Sally's happy. We're tracking the operators in the logical structure, so we can see here it's a statement. This is clause level, positive, polarity, present tense. We have our logical structure. Sally feels happy, so it's not be happy, it's feel happy. So we're just following the RRG textbook. And then we have our arguments down here, or nucleus in this case. And you can see we've given definitions. So all of these things are being tracked as a perfectly symbolic system. There's no statistics involved at all. So P colon happy means it's the predicate happy. Here's the predicate be as an auxiliary, and here's Sally, a woman's name. So at that point, in the upcoming book, we built our system based on examples like this. So Daniel limped 1 mile away to the church. So in order to recognize the breakdown, let's see, in the 2005 book, there's like 2 pages that explain all the interclausal semantic relations. And one of them is there's means and manner. And so when you think about motion, if you pull out the manner, it's really convenient for handling the processing step of all of the other arguments for motion to simply be able to expand that to the manner is limp. So you're moving, the manner is limp, and then this is the latest. You probably haven't had a chance to see it yet because I haven't got the book myself yet. But there's a process going on which covers a path. There's a distance where Daniel's moving a mile. I'm not sure if this is the right way of formulating it yet. In the process, the direction of motion is away. And at the end, this used to be the ingressive one, Daniel's at the church. So that's limping 1 mile away to the church. And what was difficult about that was that we'd set it up as a nice 2-role predicate, and suddenly this distance comes in, which meant we had to reconvert it into a 3-role predicate and then deal with that correctly. So if we take that sentence there and we add another role, just to show that it's quite happy to be a 3-role predicate. I won't use limped because we'll say walked the dog 1 mile away to the church. We're still, let's see, getting the same type of relation. Now it's a causal form. Daniel does something which causes the dog to move. The manner is walk, not limp anymore. It's still got a distance of 1 mile and moving away, etc. So we're basically handling the same thing, and all of those great steps that Van had in his presentation are all embedded in there somewhere. So what I say to the team that's doing this, the testing for us, is if RRG says this is what the answer is, that's what we aim for. And our test says this is the answer, and then we just make sure that the system does what we say. So you're getting a feeling for just how the system's working? I'll now show you just something that came up in a meeting. We were talking about, you know, what's the potential of this type of system, and to me the potential is if we just keep improving the system over time, we're going to have something that could consume anything, have it in a meaning-based format, and then generate it into any other language. So here's a nice simple sentence from PubMed, the medical online journal. In PSS, interleukin 33 is released in the extracellular space from damaged salivary cells upon pro-inflammatory stimuli and or dysfunction of epithelial barrier. So nice sentence that you'll often use when you're out having a drink on a Friday night. And the breakdown was interesting because Van pointed out that there's this topic that's in there in PSS. So think of it in the New York Times, I read this. So in PSS, there's a piece of context. and then we have the rest of the context to store here. And I got help with it from Van. So the causa here is the pro-inflammatory stimuli and or dysfunction of epithelial barrier, I think the rest of that is. That's not fitting on the screen. So interleukin-33 is our patient, and it moves from the damaged salivary cells into the extracellular space. And there's our logical structure that shows it, and we have the ability to drill down into the components, like we've got a conjunction there. And the principle we took is we'll try and be human level. I think humans can remember 7 plus or minus 2 things, so we allow up to 9 of these conjunctions in a sequence. So number 1 is the pro-inflammatory stimuli and or the dysfunction of the epithelial barrier. So we just store the conjunctions, and that allows us to then resolve them all with the predicates, selectional restrictions when we're doing this matching. Just to prove to you that this isn't just all magic and what have you, if we just run that same sentence again, I'll show you the sequence that we're following. Pattern brain theory is the theory I developed in the 1990s, where all we can do is have symbolic elements, probably the simplest way of putting it. So here what we're doing is we're matching the symbolic elements, which are the words, and dashes and the like. And if I were to open that, I think it's probably that one. You can see we're just starting with the first word, and then we're adding the phrases that match after that we've already matched. So this interleukin-33 is being matched against interleukin-33, and at the very end we match it with the topic. So we're not following the sequential sequence, because you can't really find the sequence until you've matched the interior pieces, and then you can combine it all up. And this isn't a particularly interesting one to look at, because you can see we're just at the same endpoint there. If I go back and look at the recognition of the main clause, interleukin-33, you can see that we're recognizing firstly the word, and there's a phrase in there, is released. So on this side, what we're doing is we're matching syntax first with something like pre is the naming, and SS is semantic set. So we've split the recognition of a sentence into syntax first, and then we validate with the semantic set after that. And that way we can have embedded elements matched ahead of the whole sentence. I mean, you can see there's a bunch of different types of things. It's released in the extracellular space as some sort of put. If I click on that, you can see the meaning of that simply based on this predicate released. Okay, how are we going for time, Beth? Okay. So that's just a quick introduction to the meaning matcher. I'll show you some of the more of a variety. Let's go back there. Let's clear that. In terms of what we want linguists to do, it's come up with lists of valid sentences that the predicate uses. That's probably more visible to you. So the savant quickly proved the theorem. The savant quickly proved the theorem to the professors. We're looking for the longest number of arguments that predicate takes, and then we're coming up with a sentence for it. And then down here, we want to do that as a it cleft and vary all the argument positions so that we're still getting the correct results. And because this university is also going through a process of bringing in NLP experience, we'd like to be partaking this and applying it to Spanish, because I think the principles are pretty straightforward. So if I take this sentence, which is the nice one with the verb, the savant quickly proved the theorem to the professors, you can see that we've marked these arguments, and this applies to Van's 2005 book. Quickly there is one of our periphery elements, and there's our representation. Quickly, the savant did something which caused the professors to know that the theorem is true. And you think, okay, well that's kind of obvious. So then if we take this one, it is the savant that quickly proved the theorem to the professors. This has to work too, and why do people talk this way? I don't know, but we need to be able to recognize it and correctly break it down. So the savant that quickly proved the theorem to the professors, that's about the savant, and then we've got relative clause. And when we drill down into that, we get the nice logical structure again. Quickly, the savant caused the professors to know that the theorem is true. So that was our it cleft. The other thing that we care about is the nominal forms. The quick proof, let's see, the quick proof of the theorem was difficult. The savant's quick proof of the theorem, when we drill down into that. And sorry, I'm going pretty quick. I'm just trying to show the overview of these things. Otherwise, I'd be talking for a long time. So here inside it, we've got proof, which is showing as our predicator. The savant is the thing that is doing the causing. And again, we haven't got the professors in this example, but what are we showing here? The savant's quick proof of the theorem. That's the text that we've matched that then maps onto this logical structure. So the idea is if we can take linguists and people that are native language speakers, get the list for the predicate types, get all the predicate categories that exist, test all of those at least once, and then take all of the words that belong in a predicate class and add them, then the system's going to work. And if it doesn't work, well, we should catch it in a test. And I've got one more group in the meaning matcher category that's interesting. This one, junctures. So when I found RIG in 2012, I was blown away because I thought everything has to be syntactic matching first. And suddenly RIG talks about this thing called junctures. I'm thinking, what is this? But I always wanted to understand, if you're happy to go to the park, what's the happiness in the park? What does that even mean? And I mean, I speak English as well as I do with this funny accent, but I didn't understand the meaning of English. And so the remarkable part was to find that there's this mature theory called role and reference grammar that not only explains syntax, but it explains semantics. It talks about discourse pragmatics that I'd never even heard of, and it took me years to be able to pronounce that. And so here we've got just showing you that it does work. If you persuade somebody to clean the car, for statistical people, sorry, I'll make that bigger. We put this big line here in the middle to show that that's where our juncture is taking place. So Beth persuades John, and then because John is the variable that gets brought forward into the rest of the sentence, John cleans the car. And so obviously if you're persuading somebody, you're taking the undergoer and you're bringing it forward to the other side of the juncture. And if you promise, which was this next example, then this is the much better example, because here Beth has to clean the car rather than John. Out of the role and reference grammar examples, what does promise mean? It means somebody says something to someone else which causes that person to become obligated to do the thing that's coming up. And in the statistical world, I like these examples because what it's saying is that anything can come after that too, at the other side of the juncture, anything. So it could be a state, it could be an activity, and statistically you'd have to capture all of that in order to have a good statistical model, and it's infinite. Last example here in the meaning matcher, Beth seems to want to try to persuade John to start to eat the fish. The technique that we use is to carry forward the representation. So you can actually follow this in real time by seems to want to try. So there's it seems, X, to want, Beth wants something. And what does she want? She wants to try, because there's a state, there's an activity. And then we finally hit the real message here. Beth persuades John, so there's our persuade representation. And then finally John eats the fish, John does something, and the fish is consumed at the end, so active accomplishment. So nice application of RRG, and some of these things took a while to work out, but language isn't simple. But now that we have these examples and we've applied it to other languages, if we had native speakers in other languages, we'd be able to put those examples in and do the same type of testing. We're probably at the 10-minute mark now. So we'll move on to the conversation example. So what we're doing is we're taking text and we're converting it into meaning. Now, what happens when you store meaning and you start keeping track of it in a sequence? Let's look at the ultimate goal here. We talked with... I'll just run them all and I'll step back through it. So the man bought a car from the dealer for $1 is our sample context sentence. So how the system works is if we put in a declarative sentence, we just store it as the context. If we put in a question, we compare what's in context, and then we answer it based on what's there, if possible. So here we've got the man bought a car from the dealer for $1. And if we look at the current context, you can see there's this change of possession going on. So we're actually tracking, if you buy something, the thing that you have becomes yours, and the thing that the other person you bought it from is not. And then there's an exchange of money here, so the money's working backwards. And then there's our whole sentence. In case somebody says, what did you buy? You've got the original sentence there. Oh, and actually, while I'm here, in terms of external systems, okay, that's a bad example, because I've got all nulls, and that's not what I want to demonstrate. So I'm here, who sold the car? So sold isn't the same predicate as bought, but we know what sold means. It's an exchange as well. So when you say who sold the car, the dealer. Who received the car, different predicate again, but the man. Who did the man pay for the car? And if you do this in real time, you get lost because it's too hard to remember what was the source sentence and what's the question. But I'm pretty sure if you just said one of these, it would be easy enough. Who sold the car? The man. Who was sold the car? The man was. We're making sure that we're following the rules of discourse pragmatics with our answers. Did the man pay Beth for the car? So pay for, no, the dealer. I'm quite an advocate of, when we looked at the types of tests that were coming out of the tech giants, Facebook had an example in 2017 called conversational tasks. And we got 100% on their tasks. They could get high 80s and 90s for their tasks. So we got 100%, and we ran the tests against the training data, which found errors in the training data, which was pretty annoying for the people that thought that the training data was supposed to give them their output. Anyway, the point was they did examples like this, and you should be able to test your training data in the same way that you're doing these tests. Here's Van's example from his presentation, who was presented with a car. So if you present somebody with something, then you're giving it to them. What was the man presented with? So this one here, let's just go back to the meaning matcher so you can see what's going on. So if you say, what was the man presented with? Is this some sort of complex processing task, or is there something else going on? So if we break that sentence down, you can see here the man was presented with what? Sorry, the black thing pops up. So in the logical structure, something causes the man to have what? So if I check my context and I've got something that matches everything else, I can simply pull the what out and I can convert that into an answer that I generate. So that's the principle of the conversation engine without having to rely on any of the original words that were used. You have to be able to break the semantic representation down, which is why it's important to have a really good linguistic theory to base all of this on. Okay, so that's our goal, to be able to do this. We talked with Silicon Valley, a couple of the top guys, it might have been LinkedIn or something. They'd worked for, oh dear, now I've got to remember names. These guys were top-class computational linguists that had worked for eBay. And eBay gave them a task of, for 5 languages, work out all of the ways you can order something, because they wanted to have a natural language interface. And they said that for English they had about 15,000 sequences that they worked out, and it was just too hard. They were just almost in tears when they were explaining to me the process they went through to try and do it with early 2000s type technology. So we think that with a good underlying linguistic model, it's possible, and I'm just showing you here that you can do these types of things in real time. Okay, so that's our goal. Let's see how we get there. To me, context is the key piece that we want to be tracking. So this is out of Van's 2005 book. Beth arrived, she saw Sam, he kissed her because he was happy. I've added the because he was happy part. So what are we doing here to understand this sentence? Well, we simply store all of them in sequence and context. Right, so you can see Beth arrived, Beth's ingressive at some location, she sees Sam. Inside the details, obviously, now's the time to resolve the meaning of it, because 5 minutes later, who saw Sam might be asked. So you can see we've resolved that Beth was the one that saw Sam. and he kissed her because, sorry, it's important to see that it's just the application of some pretty simple engineering stuff. So he was happy. So who's he? If we look in here, you can see we resolved it to Sam because the conversation's not been too complex so far. So now when we go and ask questions, who arrived? Beth, well, it's there. Who was kissed? Beth was. He kissed her, so Beth was kissed in passive. Did she kiss him? So I don't know, and there's the question of what's the predicate mean? If you kiss someone, do they kiss you back? Well, we're saying no. That's just the way it's implemented. Did he kiss her? Yes, he did. Who was happy? Sam. So that was inside our because phrase. And we're just going to add one bit more complexity here. Sue arrived. So we've now got an extra female name. John walked her to the garden. And this is our help text turned on. So I chose Sue out of Beth and Sue to mean her. So we found that for most of these types of conversations, you just choose the very last element in that category and it gives the right answer. But you know, the whole point of having linguists in the team is to say, well, okay, you think that works, but does it work? Give me an example where it doesn't work, and then we have to think of how we get the system to work correctly. So when we say who walked, Jack walked her to the garden, so who walked? Sue did, because her was resolved to Sue. Who was walked? Sue was. Did Jack walk her? Yes, he did. So time-wise? Okay. Let's see, what resolution? Off. So this was an early one that I found kind of cute. The fish is off, the light is off, the party is off. So we'll just run them all. If off is obviously ambiguous, so if a fish is off, oops. If a fish is off, it's bad or it's spoiled. This is English, I can't translate, but the light is off means it's inactive, and the party is off means it's cancelled. So if you say what is off, we've retained all of those elements because off is ambiguous in the question, so we can give the ambiguous answer. What is cancelled? The party is. So we're putting in the auxiliaries in our answers because it can be helpful in some cases. Some cases it's a bit messy, and we can simplify the generator a bit. So is the party cancelled? You can ask polar questions, content questions. What is off? And so just showing you at the end, we've still retained the ambiguity of off. And time-wise, this is probably my last one. We had a real guru in linguistics do this one for us, just to upset me. Beth and John flew to London yesterday. Oh no, I've hit the wrong button. Let's pause it. So this is one of Van's examples. Beth and John flew to London yesterday. Okay, so I understood what pronoun resolution's about. They ate a snack on the plane. Oh, okay, they is Beth and John. And you can see in our help response, it's saying Beth and John was resolved to mean they. She carried a briefcase on the plane. So inside the Beth and John, we have the she, which we have to extract. So Beth flew to London, and then she carried a briefcase on the plane. So we've chosen Beth correctly. He had his backpack, so we're choosing John out of that list. It was large, we're choosing backpack. That one's got a few. So we're choosing his backpack out of snack briefcase and his backpack. I had absolutely no problem with knowing that was the only answer for the way I speak. And then questions. Who flew to London? Beth and John. What did they eat? A snack. Who carried a briefcase? Beth. So because we're resolving the context as we go, there's no complexity to get the right answer. And so the idea of processing this with, in retrospect, becomes a really much harder task to do than to simply handle things as you're receiving them. I like this question, who had what? Because that's showing the fact that you're asking more than one question. So for my friends in Silicon Valley that like to say there's one intent for one statement, I don't know how they're going to handle that one. And our answer's probably got to be generated a bit better. Beth, a briefcase, and John, his backpack, but gets the message across. And then who had what on the plane? So the only person that had something on the plane was Beth. What did we enter that? She carried a briefcase on the plane. There's a bit of ambiguity there as to, did she carry it onto the plane or did she carry it while she was on the plane? But ultimately the briefcase is the right answer. Okay, so I think we're at the point where I've just gone through the meaning matcher and the conversation engine, and whereas I think that's really interesting for linguistics, for people learning a language. what we want to be able to do is bring tools to industry so that they can use computers with language. And the technique that came out in 2014 around the chatbots, I don't think is that effective. So if we look at this concept of goal direction, this is where we want to help somebody get to the end result. So I'm just hitting the submit button to get the machine to interact with us. And I'm going to hit this refresh button because that's not how it should look. So we're just starting with some comments to the user. Hello, welcome to my world. Can I help you? I am Pat. And who are you? So at this point, there's the unfortunate, almost infinite number of things that you can say, like, I don't want to tell you. But for the sake of the demonstration here, I'm going to say I'm Mr. John Ball, which is true. And I've got this view which I'm showing you here, which is rolling around on the screen. You can see here we've got a title, we've got a first name, we've got a last name, and we've got a missing middle name because I didn't put my middle name in. So in order to navigate these types of environments for an industry, we're thinking if you had to ask people a series of questions, what's your name, what's your address, where do you work, what would you like, if you could build the data that you require in order to get the answer for them, then that might be a convenient result. So at this point, I'm Mr. John Ball. It's recognized the sentence, it's recognized the referent, which is Mr. John Ball, and now it's saying, what's your middle name? And very quickly, this would be annoying if we just kept hitting this button because you have to keep prompting somebody for the same information. But the point is that at this point, we can just enter my name and stop annoying it and annoying us. And that was all this thing was trying to do. But from a computer science point of view or from a IT systems point of view, we've now got, thanks for visiting John, so it knows an informal way of calling me, and it knows Mr. John Samuel Ball, the formal way. As a programmer, you've got access to the data, you can do whatever you like. And that's the point of the goal direction. And you think, well, you know, who cares about names? What we want is to have some sort of useful business application. So let's have a look at the One World system that we designed in 2020. We had lots of time at home because everybody was at home in 2020. In fact, we just flew back from, I just flew back from San Francisco after pitching this plan, and this is the result. So this is the live One World system that you can see. The goal of it was to take their existing system where I spent 45 minutes trying to book a round the world ticket, and after 45 minutes I'd failed. I got caught in Tokyo. It was giving me like error code 53. But what we're using here is a good linguistic trick in order to get the answer we want. It says here, from which city would you like to depart? So it's a narrow focus question, so I can say Madrid, and I don't need to type in I want to go from Madrid to wherever, and put, I don't know, around the world ticketing with, in one sentence would be horrendous. But the people at One World had said to us, can you emulate a travel agent? And when you think of it, your experience with a travel agent is almost the opposite of your experience with a system that's trying to do these things. The travel agent will say, how are you? They'll say, what do you want to do? You'll say, I want a round the world ticket, but I don't know what it costs. They'll say, oh, it'll cost about 2,500 euros for 4 continents. You say, great, I'll go and talk to my friends. I'll find out when they're available. I'll come back and book the ticket. Because now you've got your budget set. So what we wanted to do is exactly this, emulate the travel agent in all the ways that you work with a travel agent. So here we've immediately prompted for the cost for that. And so let's go and price an itinerary because we've now called our friends. We know when they're available. And so here's the question again, narrow focus. Which cities would you like to visit? And if you're like me, you don't know geography very well. And so when somebody says, where do you want to go? You say, oh, that's London, New York, I'll put in NY, Chicago. I don't know, maybe I don't want to go to Chicago. Tokyo. So this is kind of following a path, and maybe Hawaii. And at this point, most systems in the world will break because they want you to follow the rules of the airlines in order to produce it. But this system was designed to get that narrow focus, work out what we want, and then pass it to a computer to do the scheduling for you. So here we've got a point, please select the cities in Hawaii. So Honolulu, so we'll go to Honolulu. So you can apply a lot of good computer IT information at this point because it's it's just a very specific question. Give me some cities that we fly to. And so at this point, you're not lost. It's going to ask me, I've added these places. It's giving me some comments. It's giving me an indicative price. I'll set the city order. So you can see that it's automatically, let's get rid of some of these things. You can see it goes from Madrid, New York, Chicago. So it's worked out that path. At this point, you're able to change some things. So for example, change Chicago for SFO, San Francisco. I think that's a much better flight. I probably shouldn't have done it in front of an audience, just because of the time. But the point is, I'm just showing you that you can do these things. And so that's a NLP application. We're simply putting in change this to that. So we'll save that itinerary. We want to set dates. So when you speak to a travel agent, does he say, what date and time do you want to leave from Madrid? What date and time do you want to arrive in New York? You don't ask any of those questions because we don't communicate like that. So when would we like to begin the trip? I'm going to make it fail. I'm going to say in 2 months. I'm just doing this because this isn't my implementation. It's another team. So we're going to come back and do an NLU upgrade on this. It says, I think we have a misunderstanding. I expect you to provide a date. But I interpreted what you wrote as a duration. Because in 2 months, I walked to the city in 2 months, I guess, is a duration. But in 2 months means I want to begin my trip. That sounds okay to me. But I'll just say July. So here we go. It says, okay, I've set your trip to begin between July 1st and 31st. How long would you like it to take? 2 months. And that's allowing the machine to do all the hard work that me as a person would hate doing, which is working out dates and times and days a week and putting all of that into a machine that's asking me for 3 or 4 numbers and maybe a time and who knows. So there we go. We've set the duration to 60 days. Would I like to make any changes? I'll say no. And so the point is that there's a lot of scope for linguistics if we can get the language understanding right and we design our systems to work the way people work rather than the way the IT systems work. And so we call this concept next generation technology because it was a really innovative concept. Maybe next generation's not the best name. But it's now going through to the end and we could book that ticket. So my argument to the One World management team was, you can do this in 45 minutes and fail, or you can do this in about 4 minutes and succeed. Which do you think is better? Okay, so that's the demos, and I think at this point we could have some questions.
Okay, thank you. Okay, any questions or comments?
Good linguistic questions too, because I've done it.
You're
We used the VerbNet system as an example. They had something like 250 predicates. When we went through and coded up all of the ways that you could use that by varying things like the way you could handle negations, active, passive, tense and aspect, nominalization, gerunds. But when we looked at that, we finished up with a 3-word predicate having something like 1,400 tests. But then once you've got that set up, you simply put an association between the predicate itself with its word forms, the predicate itself and its word forms, and it would then take on all the properties of that predicate class. So we think 250 classes with up to maybe 1,500 sample sentences that should be good enough. We also have other types of tests, but that was a rough idea. So we're thinking maybe 6 months to get a pretty good system going with 2 linguists and 1 coder to support the testing environment. I can show you what a predicate looks like if that helps. Because it is a symbolic system. So if we looked at, say, I showed proof. So if I take this one, we actually have a later version. So this is the word proof, which is the nominal, action nominal, and derived nominal. So there's our derived nominal proof and proofs, and our action nominal proving and the provings. I don't think that's valid, but it would be matched at the moment. So we need linguists. And there's a association here to the predicate itself, the verbal form prove, and basically it's pretty quick to put in. We're putting in the 5 English forms. For other languages, there needs to be some sort of derivation going on. Prove, proves, proving, proved, and proved. And then we have a couple of associations in here to get our selectional restrictions. Things like, so the actor-verb association and the verb undergoer have to be aligned for that particular predicate. So it's not a insurmountable job. All this was very quick. Should I keep going? Oh, yeah. So today was very quick, but we have a specification that shows how to define a predicate, and there's resources out there. There's a lot of great resources that have looked at the computational approach to this, and we're having a meaning-based approach to this. Resources like VerbNet and FrameNet have lots of examples that a linguist could use to create their model. And and there's books and various things. So I think there's a lot of work that we can do very quickly for any language, really. Certainly all the popular languages that would get good, quick progress and get tests done.
Okay, thank you. I'm sorry to interrupt. It's an interesting discussion, but there is a visit in 15 minutes. So we need really to finish up now. Thank you very much for attending and for attention, and we'll keep up discussing this